Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. Most developers think that computer terms were just taught up in some college classroom. However, this is not true. Even the name computer used to be a person's job. They were people that were really good at math and they could compute calculations. Their job role was computer. There are a lot of jobs that have been replaced by a device, but the device name was changed a little bit. Like a recorder became a tape recorder, and a cashier became a self-checkout customer. Objects are no different. We as humans sit around all day and think up ideas. Well, that's what we used to do in the 60s, 70s, and 80s, and then one day the idea of encapsulation popped into someone's head. Imagine the universe having a lot of objects. Pretty easy, right? They are all over the place. Take an apple. We have dissected it and labeled everything from the skin to the juice in an apple. How about we look at it in a different way? An apple is the class. It is the definition of what we want. Say we just take the apple and paint a picture of it as a symbol of the original apple. But we have not abstracted the apple into multiple attributes, all standing on their own. The viewer of the painted apple truly sees an apple and knows everything is encapsulated in the piece of art because they know what an apple is. Classes are nothing but models of characteristics and behaviors of the objects in the world we live in. They are the ultimate data abstraction that we know of thus far. An apple can be pulled apart, but once that happens, it's not an apple anymore. The relationship of the parts to the whole and to one another are plainer when everything is kept together in one wrapper. It is also easier to transport. This is called encapsulation. I will go more in depth on this topic a little later. The topic that is just as important is inheritance, or the ability to derive a new object with all of the characteristics and behaviors of what is called an ancestor object. In 1989, moving from modularized programming to object-oriented programming was a big change for programming in general. It was also a massive intuitive leap for computer science. So what we're going to do is once we open up Visual Studio 2022 is we're going to create a new project. And we're going to create a console app. Click Next. We're going to call this application. That's just going to be our project name is going to be application. Still placed in solution and project in the same directory. I'm just going to drop it in my large C# workshop directory. Going to use the latest framework we have. I have 9.0, and we are going to check do not use top level statements. This is different from every other application that we've done because I've said always uncheck this. Click create, the template will run. After the console application template runs, you will see a screen that looks something like this. The Solution Explorer contains a solution named application. It contains a project also named application, and inside of the project you have a file named program.cs. Program.cs is also open in the file area of Visual Studio. The program file has a structure which is different than all of the previous videos that we built using top-level statements because this project was not using top-level statements. The standard program.cs files in .NET look like this since the inception of .NET. Once .NET 6 was released, top-level statements became the standard. Top-level statements are the lines of code that are within this main function. A study was done on program.cs files, and the outcome was that most developers had a standard of creating their entry point projects like console apps and services using only a program.cs file. And they would add class libraries and they would put all of their logic in the class libraries. This has since become a standard for all services and console applications in .NET. Now, there is still an option not to use top-level statements, which we did here, but I will go back to using top-level statements after this video.
Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime.
what I want to talk about in this video is mainly the structure that we're seeing on this side, because it's going to be there for every class that you create forward. It just will not be there for your program.cs file. So namespace is your outer wrapper around your classes. Namespaces are used a lot in C# programming to categorize your classes or group together like classes in one container, which is your namespace. It also uses the folder structure as a standard format. And what I mean by this is if we add a new class here, let's just call it person, add, you'll notice that person gets a namespace application just like program because they're both at the project level. Now, I could right click on a project, go down to add, and hit new folder. And let's say we call that contact. And I drag person into it. It's going to say one or more files will be moved. It'll take a long time. It never does. Just click OK. Adjust namespaces for move files. Yes, always want to do that. So what has happened is Visual Studio has updated person's namespace to match the structure that it wants you to follow. So do yourself a favor, don't go off the beaten path, just listen to what Visual Studio is telling you and let the namespaces fall into the folder structure. If I was to pull this out of contact, the namespace will be set back. So let Visual Studio manage that for you. And we're going to get rid of contact. Next thing I want to talk about is the class and the structure of the class and everything that goes with a class. A class is something that tells the .NET framework what memory to allocate and basically how to get the class into an object. But I want to really talk about the difference between a class and an object. Since this class person is in the same namespace, which is application of this class program, they know about each other. So we can put a data type here, which is a user-defined reference type that we just created called person, and we're going to name the object that we're going to reference that in memory person. And then we're going to say new person. And then we're going to put a breakpoint here, and we're going to execute this. So it'll do a quick compile, and then it'll come up. Now you can see person is equal to null. Being that it's null, it's telling you that it's acting as a reference type, or it is a reference type. If I hit a breakpoint down here and hit F10, person is now an object in memory. So this is residing in heap memory someplace. I don't know where, except for that it's in my application domain. This is called instantiating an object. This is the object. This is the definition of the object, a user-defined reference type. So what happens is when we tell it to instantiate with new, we're saying, give me a new memory for this class type, person. It takes whatever's inside of class, which could be any of these class members, could be fields, constants, properties, methods, constructors, finalizers, events, indexers, operators, and more nested types that are user-defined. And it creates enough memory space for that to exist in your application domain. So your application domain could grow, it could shrink. All right, most of the time it just grows. So we're going to define a field, and we're going to call it string, and we're going to put in here first name. And usually things that are outside facing, we capitalize. This non-nullable field must contain a non-null value. I don't know why this comes up. Well, I know why it's coming up, but I don't know why it should be coming up. Just go to your project name, double click on it. It'll open up the project file, and just disable this. Once you disable it, that error will go away. That warning will. String, we know, is nullable. It is a reference type. What they want you to do is they want you to put a question mark after it. I don't know why. It's not needed. And with the nullable being enabled, it's for a very specific case in .NET. 99% of the time, you never need to worry about it. So I always just disable mine because it's annoying. Once you set first name here, and you go back to program, you may think that you could see this right here. Like there should be first name in this list. So you can't see this here. There's no first name. You need to go back to person and you need to make this public, or you can make it internal. By default, class members are private. So if we save this and we go over here to program now, first name is available. And we can put my name in it, say Lars, just like that. Now we're going to put a breakpoint here and here again, and we're going to run it. And as you can see, before we execute the code, person is null. Once we hit F10, person now is existing, but first name is null. It's a string. You got to remember that. Strings are reference types. We go to the next line. Now person, first name has Lars in it. And at this point in time, we've actually written a pretty successful application. It built, it ran, it did what we wanted to do. So that is what a field is. Most of the time, you're not going to be using internal. Most of the time, you're going to be using public. There are times to use internal, and that's when you want to keep stuff inside of this project. Like if we had another project here, you wouldn't be able to see person at all, even if they had dependencies between them. So the next member type is a constant, and these are a little different. You come in here, you can put public, you could put const, int, retirement, age, 57. And these are all uppercase because it's a constant. You want them to stand out. Now, let's just put in here public, another const, int, age is equal to 60. If you save this off, you go back to program, you would expect to see them sitting here because they are a public. The thing is constants are static. So they're only accessible at the class level. Okay, so now you're seeing the difference between a class and an object. So if you hit a dot here on person, which is a class, you're going to see age and you're going to see retirement age. And the only reason you're seeing them is because this says public. If you make this private and save it and come back, and I hit control space to get this list to come up here, you'll see retirement age, but you won't see age. I want you to keep this in mind that these are static. I'm going to put a little note here. It says static. When we get down with the members and we start talking about these types, class types, and accessibility modifiers, then I'm going to come back to static. A property is something like this string here. So like we might make this string private. And if we do that, I usually make mine with a lowercase f. I do not like underscores. And the reason I do not like underscores is because they are used for kernel type applications, kernel type variables. And I'll get into that later. If you're interested in it, we can do that. For my backing fields, I use lowercase for the first letter. And for my properties, I use uppercase, which is standard for the very first letter. So you can put in here and put get. And we could say return first name, which is the first name up here. And you could put set and say first name is equal to value and then end it. So now these two are tied together. This field up here and this is tied together. So let me put a breakpoint in here and put a breakpoint in here and we'll run the program. And we'll run the program. So the first thing that is, well, I need to put a breakpoint here and here and just leave them there. Restart. So the first thing happens again, we're going to instantiate our class into an object. And first name is both public here. They can both be seen, but they're both null. Person first name, we're going to set to Lars. And when we do, we're going to step into the set because we're assigning first name. So value is Lars, and it's going to assign that to first name. See, first name's null, still null. Now first name is Lars. If we wanted to print this out now, I'm going to go down the same path of this, instantiate our class into an object. We're going to set Lars to first name. Now we're come back to that point, and now we're going to come up here to say person first name. We're going to step into that, and then we're going to use the get, and it's going to return Lars. And then Lars will be printed here. So it says hello world and Lars. So that is how a property works. Now you could put all kinds of stuff in here. You could call a method if you wanted to. You could do whatever you need to do in the get and the set. And there's a lot more to properties that will be in a future video. But one thing that we'll show you here is if we get rid of this, you can drop in first name. And then technically you wouldn't need this first name up here because I could drop in get and set. When you put this in, when you run this code, this all will be put in for you. So there's no more getter and setter methods. There's no more, writing so much code just to say return first name or first name is equal to value. It's a waste of time. Let the framework do it for you. Now we run this again, and you will see the exact same thing will happen, except for you're not going to step into that, but it will set first name to Lars. And when we print it out, you're going to go to get, and it will print first name. It'll print Lars right there again. So that is a really big shortcut. This has been available since about the second version of .NET. This is how all properties used to be. And then they said, hey, you can take a shortcut now. We're just going to put all this in because most people were writing this. And they found out that's a waste of our time, which there are other languages that are C languages that still do this, but they actually are one step worse because you need to write methods to do it. And that is a lot of waste of time. So there's a lot of methods that are in these languages that they just basically collapsed all the time. All right, so methods. Let's get into the methods here. You could have a public method here, and let's call it a string, and let's just call it maybe display. I don't know what it's going to say, but say we're going to return first name. So we can go up here to program. And instead of doing this person here, maybe you just want to say display. So put a breakpoint there. I'm going to stop instantiating for everybody. First name gets set. We're going to hit F11. We're going to step in as display. It's going to return first name. That there first name we'll call get, which is calling that. It'll come back. And then we write Lars on the screen. Now, why would you want to do something like this? Okay, instead of just having first name. Well, maybe you have, last name here. And maybe you have age. Right? And say age, we're just going to get rid of this, and we're going to put a get in here. And this is just going to return, instead of a string, we're going to return an int. Say we're going to return that constant. I don't know. I'm just kind of throwing something in here. So you could add something in here like this, and you could say first name, last name is age, and put your little string interpolator in the front of it. So then after we add this in, probably be a good idea to come over here and add in a last name. Like that. Then we could run this. And when you hit display, you'll pick up Lars Thurman is 60. And you pull it up. Lars is 60. Now a constructor is pretty easy. You have public, person, and this is a default constructor. Okay. It's just defaulted to person. Sometimes you need to add these in when you're doing serialization, and there could just be nothing in them, but it needs to actually have the constructor here. But constructors are good for if you want to like say string first name, and you want to set first name equal to first name, or maybe you want first name and last name here. Like that. Now watch what happens on the other side here. We try to build it. You got a failure. There is something being failed because we do not have an empty constructor. So here we would have to put in our first name and last name. So we do that by just obeying the rules. And you will still get the same response back. Lars Thurman is 60. So we go back to person here. Right here, first name could become private and last name could become private. In fact, age could become private also if you wanted to. And they don't really need to be properties at this point in time. And we could return that. We could remove a lot of stuff. And if we compile, it'll succeed. You come back to program and you will see over here that person only has display, because you're going to take all this information in through the constructor. And if you run this, you'll still get Lars Thurman is equal to 60. Because what is happening is you're going, during the instantiation process, you're getting into the constructor. There was no constructor before, so we weren't stopping at anything. And then your first name will get assigned to first name, and your last name will get assigned to the last name. And now those are sitting in memory at that point in time. If we go down to person, you can see age, first name, last name. Your static members are right here. Those are your constants, and then we can just move on. Finalizers look just like constructors, but these can only be public. A constructor could be private, but we'll talk about this later. It's something called a singleton, where you manage the instantiation from within your class. And yeah, those are pretty popular. But the finalizers are things that remove unmanaged code from memory. A lot of times we use an interface called iDisposable, which is a contract with the .NET framework for garbage collection. And I'll get into those later too. The next thing on the list, but is rarely used, is events. I don't know why they're rarely used, but I will do a deep dive on them because they're very complex and they're very involved. So like I said, that could be a whole video by itself. The extremely rarely used is indexers, and that's to make like collections, operators. So you can override operators like plus, minus, period, and then nested types. Nested types are extremely rarely used too. Not because they're complex, because they tend to confuse people. So say you've got this internal class person. I could add a public class inner class here, and someone could instantiate this class without this being instantiated. So typically these are not used just because there's configurations that have to be done and usually causes a lot of confusion. But I will have a deep dive in nested types after this video series.
Thanks for watching the video, and please like and subscribe to the channel. I really hope you enjoyed the video and are understanding the basics of classes and objects, but do not relax yet. There is a whole lot more to cover on classes. The next video will start out with static members in more detail, and this will really enlighten you about how different classes and objects are. You're always welcome here at the C# Workshop, and as always, have a nice day.